Okay, so heading into the lesson 2, ready, set, go. The first thing they give us is some equations and two variables describing quantities. And those quantities include x squared quantities, which are whatever x is, but then times it by itself. So maybe x, in this case, I don't know what x is. It's not on the grid, but whatever it is, this box is x times itself, is x squared. This long rectangle is x long and 1 wide at the top. So it's precisely x amount. How do I know it's x long? Well, it's x long. And so is this one, and so is this one, and they're all 1 long at the top. So let me clean this up a little bit. So I have an x squared, I have 3x bars. And then how big is this little square? Well, it's actually 1 on the top and 1 on the side, and 1 times 1 is 1. So these are all 1 blocks. They represent one amount. Whereas the other things are variable, it changes depending on what x is. These 4 are always there. So what if we wanted to describe this amount? Well, we have an x squared amount, and we have add to that 3 x amounts, and add to that 4 1 blocks. That even if x is 0, let's evaluate for 0 real quick. Let's say this is a function we've defined as a function with the input x. We're going to put in 0. What is 0 squared plus 3 times 0 plus 4? Well, 0 squared is 0. 3 times 0 is 0. And there's a 4. So when this expression, when this polynomial, when this trinomial, when this amount is evaluated for the situation where x would be 0, we get 4. Because those 4 1 blocks are just sitting there. It doesn't matter what x is. Okay, so this is a great form. It's called the standard form. It's a great form of quadratics. It's different than vertex form, which is the graphable, easily graphable parabola one. This one is not as easily graphable, but it is still useful nonetheless. You may have just noticed that it tells us the y-intercept, where x is 0. It tells us what the y value is here at the end. But we'll get into that later. For now, let's just give these things, these terms, we'll give their coefficients their name, some names. So the number of x squares, because imagine a different situation. So now this is going to be a different number where we had 2 x squared amounts. And let me throw in an extra x bar and an extra 1 by 1 block. Okay. Get rid of all this. It's another x squared amount, another x bar amount, and then another 1 by 1 block. Let's see if I can erase this. Yep. All right. So now we have, what do we have all together? 2 x squared amounts plus 4 x bars, don't forget the new one, plus 5 1 by 1 blocks. All right, let's name these amounts. So the amount of x squared, which is the coefficient of x squared, we will name it a. Now, whenever there's a number in front of the x squared, we'll say that's the a. The amount of x bars, we will name that b. And the constant amount of quantity that doesn't change when x changes, but is always present no matter what the input is, we'll call that c. C for constant. The a and the b are just because those are the first 2 letters of the alphabet. So we have our a amount, 2. We have our b amount, 4. We have our c amount, 5. And so that is that. Those are just called coefficients. A coefficient is a coworker number. If you're very efficient, you work fast. If you're working with someone, you're a coworker, coefficient. It's a helpful number. It's working with the x squared amount. So 2 is the coefficient, and we name that particular coefficient a. Here 4 is the coefficient, we name that coefficient b. And here this is a constant, we name that constant c. It's actually a coefficient onto the 0 power of x. but no one writes that because x to the 0 is 1. Yeah, remember anything to the 0 power is 1. Weird, huh? But that just means 5 times 1, which is 5, which is, why do we write this? We don't. Okay, bonus knowledge with Avden. How far are we in this thing? 5 minutes? Okay. Hold on. A couple tricky things. What if it looks like this? Now A equals 1, because there's a 1 here that no one writes. B equals 0, because there's no x term. There's just an x squared term. And C equals -4. Yep, watch out for your signs there. Okay, what about something where we have like -3x squared plus, or let's do -6x. A is -3, B is -6, C is 0, because there's nothing here. Okay, what if you have something like this? Well, it's not in standard form yet. Some sort of factored form with factors that can be multiplied. Let's multiply them. Distribute, okay. Now A is 1, because there's a 1 here that no one writes. B is 3, and C is 0. Okay. What if we had this one? Again, not in standard form. Let's get it into standard form. Multiply in there. Watch your signs. The 2 is positive, the 4 is positive, so that's positive. Just grab the signs of the multipliers, and then whatever the multiplied sign is the sign that goes there. Now gotta combine like terms. Looks like we get x squared plus an x plus 20. So A is 1, B is 1, C is 20. Then there's a graphing section, which is just like yesterday's worksheet. So check out that video for how to graph vertex form. And then they give you some tables, and they ask you to find the vertex and the line of symmetry and the x-intercepts and whether it has a minimum or a maximum. So you look at the outputs: 50, 43, 38, 35, 34, 35. Hey, the turnaround is right here. So there's the symmetry, there's the mirror image, so the vertex is at -4, 34. The line of symmetry is at x equals -4. Wait, is it going up? Let's see, it's going down, then it goes back up, 34, 35. So that's a minimum. The vertex is a minimum. And lastly, it asks for x-intercepts. There aren't any in my table. There are no x-intercepts for this one. Haha, it's floating up there in space. So let's look at one more. Okay, and then I misread the instructions. So that's not actually asking you to find the x-intercepts. It's asking you to say how many there are. So in the last problem, there was 0. How many in this one? Well, the outputs are 10, then -4. Hey, well, already something happened there. It went through 0. So just as a sketch, let's see, we're up at 10, 10. Let's say that's up there. And then we're at 11, -4. So even though it's not in the table, mathematically we know that the relationship must pass through there. There's an x-intercept. And then it goes down, 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 down. And we actually stop the table here at -14. But we know it's going to keep going up. We know there's going to be another one. So 2 x-intercepts. There's the turnaround. So there's the vertex. It's got a minimum. All right, I think that's enough. Have fun with the second homework. Yay!